Now, so speaking of this first, let's do work. Work is basically defined as that it is said to be done when an object moves a displacement in the direction of force applied to it. Now, writing, this, that work and that force are generally parallel, which is very, very important. So, you guys need to remember that work is given by force times displacement. The SI units of work are joules, and it is a scalar quantity. Now, so I want to show you two different things. Case 1, case 2. So in case 1, suppose there is an object there is a force applied, and the object basically moves to a new location. And moves a distance s like this, right? So we can say that work done in this one is force times displacement. So that's fine. However, suppose this is Earth and there is a satellite that is basically revolving around the Earth. So the force is applied here, and it's moving a displacement like this, right? So velocity like that, whatever. So here, work done is 0. The reason is that basically it does not cover any displacement parallel to that particular force. Is it clear, everybody? Aman and Aisha?
Yes, sir.
Interesting. Okay. So now, then let's talk about case 3. So you have a slope angled at theta. This is the vertical height, h, and this height is s. Okay, this length, not height. So there's an object that basically rolls from the top with a weight W to the bottom. Okay, it's going from here till here, so it's rolling. The thing is that there are two ways of finding the work here. First of all, we could say work done by gravity would be equal to W times h, because that is the parallel, distance to the force. Or it would be the same value if we find two components that you already know now how to. That's theta. This will be W cos theta. This will be W sine theta. So you can take W sine theta times S. So both will give you the same answer actually. Is it clear? Yes. So the point is that if you take W as the force, then you need to know the height. Do you understand? And if you take the components, make the components like you make parallel and perpendicular components, so you make this component. This means that you need this force, so then you will use this distance because that's parallel to it. Both will give you the same answer. Do you understand this?
Yes.
So I just want to tell you that it is essential to find the force that is parallel to that particular distance, or a distance that is parallel to that force, to find the work. Okay? I hope that's clear and you will always remember this. Now, so then going to the next one, gonna basically go towards energy. Energy is defined as the capacity to do work. Again, energy has the same units as work, and it is a scalar quantity as well. So there are certain types of energies that we're going to discuss today. First, let's look at the potential energy. So potential energy has three different forms. So it has elastic potential, it has gravitational potential, it has electric potential energy, right? So there are three different types. Then after that we got kinetic energy, okay, then chemical energy, then thermal energy, then light energy, sound energy, nuclear energy, and internal energy. Now, each energy does a different kind of work. Like for example, if we talk about the elastic potential, that is basically due to change of shape of a body. We could also take gravitational. That's due to attraction of gravitational force. Electric potential due to electrical movement of charges. Could be like that. Then you have kinetic energy, that's purely due to movement. Chemical energy, that is stored energy in chemical reactions. Then you have thermal energy. Thermal energy is the same as heat energy. There is no difference really. Light is the energy carried by photons. Sound is the energy due to longitudinal vibrations. Then nuclear energy, energy due to fission or fusion. And internal energy is basically sum of kinetic and potential energy of a body. Is it clear, everybody? Right. So just remember that energy can have many forms, and these forms can change. As we know, the law of conservation of energy. Now this law we've studied since we were very young. So energy can neither be created nor destroyed. It can only change from one form to another. So you can't just create energy, you can't just destroy it. You can just get energy from one form and then convert it to another. That's how things work. Okay? For example, they've shown a trolley, H1, H2, like this. So it says that basically a trolley starts from rest at X and reaches Z and comes to rest. Right? The energy changes in this process. So as you can see that it starts from a higher height, but soon it basically loses, it loses gravitational potential, it goes to kinetic. But it doesn't go back to the same height. It means some of the energy must also have been converted to other form than, gravitational and kinetic energy. So we can say that from X to Y, gravitational potential energy has gone to kinetic energy plus heat, because otherwise, it would not lose that energy, right? And from Y to Z, kinetic energy was maximum, so it has gone to gravitational potential energy with gaining height plus some heat, because it does not go to the same height. Some of the energy has gone to heat as well. Is it clear, Aman, Aisha, Javeria?
Yes, sir.
Okay. Now, hello Ahmad, how are you?
Yes, sir.
Ahmad, that's too late.
Sorry, I got busy.
Ahmad, I actually moved class like 15 minutes ahead, like 20 minutes ahead of time for you, okay? Please do join on time, okay?
Oh, sorry.
Okay, now you gotta watch the recording, okay? Make sure you do. Now, so in our course, we also need to learn the derivation of gravitational potential energy and kinetic energy, and they might ask you for 2 marks, sometimes even more. So let's try and figure out how they're derived. So for gravitational potential energy, we're going to learn the derivation, and to start off we'll write that work done is basically given by force times the displacement. Number one, force due to gravity is basically weight, and by now we know weight is mass times gravity, and change in height is h, whether you move like towards a planet or away from it, doesn't matter. So when you put it inside, you see that work done would be equal to force is mg and displacement is height. So basically you get the work done by gravity as, against it as gravitational potential energy, and that is mgh. So you already know this, right? Very simple derivation, usually 1 or 2 marks that comes. But most importantly, about kinetic energy. Let's do its derivation. For that, you need to draw the graph. Okay. Suppose we have velocity time graph. And time seconds. And like this. So initial velocity is 0, final velocity is v, and it moves to final velocity in time t. So now let's check it out. So first of all, we know that work done is force times displacement, and we also know that force is equal to ma. So what we can do is we can write as work equals to ma times s. Now check this out, please. In kinematics, we learned a formula that 2as equals to v square minus u square. So what I can do is I can actually make s the subject, and it will be v square minus u square over 2a. So I just divided 2a on the other side. And then what you're going to do is you're going to replace this s right here. So if I replace this is going to be ma times v square minus u square divided by 2a instead of writing s. Now from this you can see a and a will cancel out. So I'm left with m times v square minus u square over 2. Now take 2 there, so work done will be half times m times v square minus u square, just like this. Now what you're going to do is you're going to put the values. So since u was 0, so I'll put it inside. So half m v square minus 0 square, this is going to give me half m v square, which is equal to the kinetic energy. Is it clear, everybody?
Yes, sir.
Okay. Now now we know the formulas and everything. So let's try and do a question related to this. You guys have written this, right? In about 10 minutes when the meeting ends, please rejoin, okay? So it says a small mass released from rest at point P on a frictionless smooth hemisphere. Let me draw this first. So they've basically shown different places. P, Q R S and T. And they've given the velocities as well. So in here, its velocity is 1.0 meters per second. Here, the velocity is 2.0. Here, the velocity is in fact, I should write, it starts from rest, right? 0, no velocity actually. Here 1.0 meters per second, 2.0 meters per second, here 3.0 meters per second, and here 4.0 meters per second. So they've given the velocities. Okay. Hello. मालिक साहब, बस मैं कॉल करता हूँ आपको, ठीक है, थोड़ी देर तक. Okay. So then the mass loses, says gravitational potential energy E in falling from P to T. Okay, so it says like that. It says at what point the mass has lost GPE by a quarter, which is E by 4. So this is the question. Do you guys understand? The question is? Okay, everyone? Now, so basically, when the speed is 4, it has lost the gravitational potential energy by E, and wants you to find at what speed and at what point there might be it will have gravitational potential energy of E by 4. Can you guys try this, please? Let me know if you can do the answer. You get the answer. Okay. All right. Aman, Javeer, you guys got the answer or no? Okay. So basically, there are two methods of doing this. So I'm gonna teach you both of these. Let's see what you can, do about it. So the first method basically involves ratios of math. It's up to you if you want to use it, right? We know that gravitational potential energy lost is basically gain in kinetic energy. We know this. Gravitational potential energy, he says it's E when you have half mv square. Now the mass and half stays the same. So E is directly proportional to v square. So let's just think about it like that, right? Whenever the proportionality sign comes, you can basically change it to a formula. What you can do is, so energy 1 over energy 2 can be equal to v1 square over v2 square. So basically you can relate them to directly like this, okay? Now what they want is, they say when the energy was E, the the velocity was 4 whole square, and we can see that at t it was 4 square divided by, he says that when energy was E by 4, what would be the velocity be? Okay, so we can just do this. So that would actually mean that E and E will cancel out, or you can just simply multiply this. So you can say, okay, E times v2 square equals to 4 square times E by 4. E and E will cancel out. This will get you v square. This will be 4 square is 16 divided by 4. So v2 square, 16 divided by 4 is 4. So you take under root on both sides. So v2 will be 2. And 2 meters per second is the speed at exactly r. So we can say that it reaches E by 4 at r. Do you guys understand this?
Yes, sir.
Okay, let me do this again. Show you how ratios work. Basically, whenever you get a ratio sort of thing, right? I just want to tell you this. This is our main equation. Like you have gravitational potential energy here, and you've lost all energy, gravitational potential to kinetic here. You agree? So the gravitational potential energy E is there, and it was half mv square. Now what you're going to do is you just need to look at the constants. The constant values throughout these equations are going to be half an m. So can I write this as E will depend on v square only, because the speed changes and so the energy, right?
Yes, sir.
Whenever you see this, because this is like a proportion, basically what you can do is you can write that E1, so we're talking about one condition, over E2, we can take a ratio like this, will depend on V1 square over V2 square. So basically it's like E1 is directly proportional to V1 square and E2 is directly proportional to V2 square. Do you understand this, what I'm doing?
Yes.
It's just a method to, equate ratios. Now, what you do next is, because he said it had lost energy E when it reached T with the speed was 4. So I'm gonna write E here and V as 4 square because V was 4 at T. Got it? What would be the velocity when it was at quarter E? So we want to find this V. Do you understand V2?
So why are we keeping energy equal to 4 square?
Energy equals to?
4 square.
Come again? Sorry, I didn't understand. Javeria?
Sir, the first step that you did, and you skipped like energy equal to 4 square. So why are we doing that?
Force. Energy equals to half mv square. That's what you're talking about.
Yes.
Because kinetic energy is half mv square, right? And they said gravitational potential energy is equal to E.
Okay, sir.
Okay. Now, even if you don't, you can also do it like this. I know E basically confuses you. So instead of this, let's write GP. Doesn't really matter. I'm just teaching you how to make this ratio. So can I write like this? Any issue? Okay.
No, sir.
Okay. So can I say GPE 1 is equal to V square divided by GPE. I'm just making two conditions. That at first condition it was V1 square and the other condition GPE V2 was square, like that. Do you agree? Write like this, right?
Yes.
Now, he says when the gravitational potential energy it lost was E, so the speed was 4 meters per second and it was at T, right? So the mass loses E in falling from P to T. Agree? So what will be the speed when it has lost a quarter of the total energy and we want to find this V2 square? Do you understand?
Yes.
That's just a way to make a ratio. Now, so what you can do is you can basically cancel the E out, multiply 4, or you can just write it like this. E times V2 square equals to 4 square times a quarter E. Can I write it like this?
Yes.
E is on both sides of the equation, so I can cancel this out. So V2 square will be 4 square is 16 divided by 4. So 4 divided by 16 is 4. Now V square under root and 4 under root will be equal to just 2 meters per second, and that's at R, as you can see the drawing. Okay? Do you understand? So that's just a way of, creating a ratio. If you like this method, this involves maths, of course. If you like it, you can use it. Otherwise, you can go towards method 2. Okay. Now let's do method 2 and you'll understand the same way. So again, we know gravitational potential energy that was lost would be the gain in kinetic energy. Okay. Gravitational potential energy is GPE and gain in kinetic energy is half mv square. Okay. Now, let's assume, and this is when it has the same mass is equal to 1 kg. It doesn't really matter because mass is irrelevant in ratios. Now, let's put it in. It lost E according to the question. I'm putting 1 as mass when the speed was 4 square at position t. Do you understand? Right. Now, so this would make the energy, if it was just 1 kg mass, it would have lost 16 divided by 2, 8 joules of total gravitational potential energy. Do you understand this? Now, the question says, what will be the speed at E by 4? So, what is E by 4? So, we can say that E by 4 is equal to 8 divided by 4, which is just 2 joules, right? Is it clear? A quarter of total energy is 2 in this question. Any question? Now, let's put it this way. So, GPE now lost is gain in kinetic energy. So now we have to find how much speed was there when it has lost 2 joules. Half mv square. So 2 equals to half. Mass was 1 and we want to find this. So 2 will multiply there, it will be 4. V square, you take under root. What you get? 2 meters per second, and that's the same answer at r. Do you understand this?
Yes.
So whether you take the actual value or the ratio, it doesn't really matter because you're gonna end up with the same answer. And typically these difficult questions basically test whether you know that the mass is the same. Even if you had taken mass 2 kg or 3 kg or 4 kg, whatever value you would have taken, you would get the same answer at the end because mass is irrelevant. Is it clear? Aman, Hamad, Aisha.
Sorry, after the 2 equals half 1 v squared, where did you get the 4 under root?
I multiplied this half, multiplied there, so 2 times 2 is 4 now. You see? You get my point? I like the ratio ones because basically in ratio ones, right, you just need to understand the gravitational potential energy. It is basically, it will always depend on this. So you can always, see what are constants, just remove them and then make a ratio like this and it will give you the answer rather quickly. I did it like a long way because I had to explain you. Otherwise it takes like less than a minute to do that. Okay. Alright. Now, so from here, we basically will stop here, and in the next class, I will actually I will finish this. But before that, I want to give you a worksheet this time. Okay, I'm gonna post that.